Hi guys, yeah, welcome on board. So I'm Bharat. I'm the founder and CEO of Appamate. Appamate, we've been in business since 2012. It's been a good 12 years since we started the journey. We originally started as a purely software development agency, as an app development company, like most other companies start. But during the journey, we realized our mission is actually helping founders succeed and not just developing apps. So we have gone from building apps to becoming a full service agency, doing everything from design, validation, the actual coding, the launching and go to marketing of the apps as well. So we do the end-to-end services, and our mission is really to work with founders and help them succeed in their startup journey. So we've been running these webinars for the last 12 months in partnership with different startup agencies like the Startup Network. We are part of the Fishburners in Sydney. We're also part of Stone and Chalk. So we run these webinars for different startup networks. And So far, we have done different events on strategy, on marketing, and this is a topic that's been asked by the audience. People wanted to know, hey, tech stack, it's just too complex. There's just so many options out there. How do we go about making the choice of tech stack, and how do we go about making our choice of tech stack? So we thought we'll put a session together on that specific topic based on the audience request. So that's what we'll be going through today. So we'll be recording the call today. So yeah, if you have any questions, you can just raise your hand in the Teams. So you should be able to see a hand icon in Teams if you haven't used Teams before. So you can just raise your hand there, or you can also use the chat window and pop your questions there. So yeah, so Bharat again, founder. I'm based here in Melbourne, Australia. Rakesh is based here in Melbourne, Australia too. So yeah, the deck here, you can see some of our clients we have worked in the past. So One Giant Mind is a meditation app. They have over 1 million users. Find My Player is a golf sporting app for following golf players. These are some of our recent launches. VPass is a B2B SaaS app. They have over 300 schools using their app. They're, past the product market fit stage. They're in 7-figure revenue stage. Emotional Pulse is a mood tracking app. So we work in a variety of niches within the mobile app industry. Our focus is, mobile apps and SaaS. We don't do game apps, but we do kind of every other kind of apps within the B2B and B2C space. Sports apps, wellness apps, yeah, business apps, emotional tracking apps, all these kind of apps. We also work with a handful of larger enterprise clients like L'Oreal, Adidas, but that's not our bread and butter. They come to us and they ask us to work with them. We do that in that case, but our focus and our mission and our passion is really working with startups and founders. So with that being said, I'll hand it over back to Rakesh to take over the session. Off to you, Rakesh.
Thank you, Bharat. Just one request. If anybody is raising hands, I may not see it because I'm in full screen. So Bharat or Shanta, please call it out if anybody
Yeah,
raises their hands.
yeah,
Thanks
I
for
will do.
that.
I will do.
Sure.
And love to hear from you guys too, like where you're all based. So as Rakesh start the session, if you guys all on the chat, just put a little note on where you're connecting from, and then how did you hear about us? Did you hear about us through your startup network, or did you directly get an email from us? Just let us know those couple of things in the chat, where you're from, and how did you hear about the webinar?
All right. Thank you, Bharat. So thanks everybody for joining again. So now you have an idea and you want to take it to fruition, but what do you do next? There's so much choices out there. It's overwhelming, it's bewildering, and you approach a consultancy and they give you lots of tech jargon and you don't know what to do. So let's see what they're talking about, what the pieces are. And in this presentation, we'll talk about all the options out there, and not all the popular options out there, because there's way too many to cover. If we start talking about everything, we're going to be here all day. So we're going to cover some of the popular ones, and then tell you why they're popular and how you can sift between those options to choose the right one for you. So when you have an idea, maybe it starts off as just an app, right? So maybe it's an app, maybe it's a website, and maybe that's all you need. So in your stack, all you have is an application. But sometimes you also need a backend. where you need some data that is managed by computers, servers that are managed by your organization. So that now becomes a full stack. So that now you have a deeper tech stack. You have the front end, you have the backend services, and often you have a database where all of your data is stored. You can go further, and now you can integrate third-party services like authentication or push notifications or SMS, email alerts, or market tracking, cryptocurrencies, and all that. So that is where vendor services come in. Or you can go all out and build what is called as a distributed architecture, which is reserved for most advanced of projects. Most startups probably won't need this. Most startups will just do either a front end only tech stack or a front end and back end tech stack with a database backing it. If you are the kind of startup that needs a distributed microservices architecture, you'll probably already know it. So in this tech stack, what are the main parts? The first thing that you see is the thing that the users use, which is either the website or the mobile application or a desktop application. There are lots of cross-platform tools available for mobile and desktop. That is what we'll be focusing on. We will not look at the platform native tooling, because as the startup, your focus would be on maximizing the bang for your buck. So you want to write code once and you want to deploy to as many platforms as there are out there. So there are solutions that allow you to build once, deploy to web, mobile, and app. And then there are solutions where you deploy once for the web, and then you make another project for the mobile platforms, which is separate. We look at all those options. And then when you come to the back end, there are, again, lots of ways you could go with it. I mean, compared to the front end, the back end has even more choices. There are technologies dating all the way back from the 90s to the latest stuff where you have AI-based backends and stuff like that. So today we'll just look at the most popular types of backends and look at one or two options in each of those. And then, of course, all of your data needs to be stored somewhere. That is where a database comes into place. And again, there are multitudes of choices. So we look at some of the popular types and one example of each. And then vendor services. Vendor services, like I said, could be third-party services like authentication, notification, or even AI. We won't cover vendor services because there'll be way too many to cover today. Maybe if you guys are interested, we can have another session at some point. But we look at all the other pieces that you probably need. So let's start with the website. This is probably the most common option. You build a website and then that's it. You don't need anything else. That is your startup. Right? So let's see what your options are. One of the most popular, actually, at this point right now, the king of website development for modern projects is React. React is a framework developed. Sorry, that is not correct. This is some editing snafu. It should say Facebook. React is developed and maintained by Facebook. It was originally created for the Facebook website itself because they needed technology that they can use to rapidly iterate and simplify web development. And if you search the internet, you'll find way too many projects that use React. It is popular among enterprise application developers and also young startups. And you'll find React in various flavors. So you'll find people using React out of the box, or you'll find people using other solutions like Next.js, which is a React-based framework, which provides a lot more batteries included kind of framework. So what is React and why is it popular? React is a way of writing UI in a declarative manner. So in that, you just describe what your UI looks like, and then you describe what your application is doing at the moment, and then you just wire the two. You don't have to say when the user, let's say you're building a to-do application, right? And you're adding a to-do. So you just add the new to-do to your to your data, and then the UI will automatically update to reflect your changes. And that is what React provides. And that is why people love React, in that you don't have to do them, you don't have to write code to make the changes yourself. You just describe how your data translates to UI, and React will take care of it. So why is it good? It's very performant. React has been optimized over the years to be super fast. It's got a very rich ecosystem. It is being popular. There's a lot of developers out there writing libraries and components and tooling and all that to make React better. Strong community support, which is what I just mentioned, and flexibility. So React is not a batteries included framework. It has got just the tooling to generate the UI. You can now add other tools on top of React to get exactly what you need. You can add tooling for styling. You can add component libraries, which give you different look and feels. You can add a complete a development tooling like Next.js or Vite and all, which provide various advantages to developers to make React-based applications. The cons are there is a learning curve. If you, let's say, are a budding developer who knows HTML, changing over to React and base technologies is going to be a bit of a steep climb, but once you get over the hill, it's much easier. The other thing is SEO challenges. So most JavaScript-based web front-ends usually run inside the browser. What that means is that when Google or any other search engine is crawling your website, all they see is like a blank page and a bunch of JavaScript. So when it's trying to index your website, there's nothing there, right? So that is an SEO challenge. Of course, there are solutions to mitigate that, called as server-side rendering and all that. But it is not, again, something that's available out of the box. And that being said, the search engines are already aware of this issue, and because more and more websites are using React, they are building solutions to mitigate this. So their crawlers are now smart enough to know that these applications probably need some JavaScript to run before any UI appears. So they are taking care of that. Next on the list is Angular.
Okay, quick interruption.
Sure.
It might be worth it to just spend a minute on what you mean by batteries not included and batteries included, because that might be a bit technical thing for people to understand.
Yeah. So when I say batteries not included, it means that it leaves a lot of choice to the developer. So the React is just a core framework that just lets you build simple websites from your estate, right? But if you want things like styling, you've got lots of choices. If you want things like components, you've got, again, multitudes of choices. And these are choices you will have to make when the project starts. You'll have to choose, what tooling do I want to start with? What component library should I be using? What styling tools should I be using? What other third-party services I should be using? So it doesn't dictate any of these things, which is a pro in some terms, but also a con, because now you not only have to choose React, you also need to know what other libraries and frameworks you need to bring in to get your project started. So there is a there's a paralysis of choice in the JavaScript world, and it bleeds into React itself. So that is why anytime a framework doesn't make a choice for you, it's going to be a little bit harder to get started. That being said, there are, again, frameworks out there which make some of these choices for you, which are very opinionated. Next.js and Vite are popular choices that people make when they make a React application. Next up is Angular. So Angular is Google's alternative to React. Right, so it's a slightly different framework, and it's far less popular than React, and it's popular among enterprise developers and stuff like that. It has a lot of similar philosophies to React, but your knowledge is, of course, not transferable, though. I mean, if you know React, you can't switch to Angular and vice versa. So once you make a choice on your front-end framework, you're probably going to be sticking to it through the life of your startup. As it says, it's used by a huge number of developers out there, and Google claims that upwards of 2.8 million websites are running Angular, but still doesn't compare to React, which is because it is still the dominant in modern web development. Angular is known for its slightly gentler learning curve because it uses more classical UI development approaches. And it's got lots of built-in tooling, so you don't have to bring in external libraries and frameworks to get your to solve your basic problems. And it has excellent documentation and active community support, just like React, though, in that particular last particular point. Cons being there is less enterprise adoption compared to React. Sorry, our slides are a little messed up. I think those points are for a different slide. Apologies for that.
Okay.
Yeah, anyway. So yeah, Angular is slightly less popular than React, as I was saying, and then so that means that there is far less choices when you're choosing a UI library, UI framework, and that sort of thing, component library, and that sort of thing. Oh, and I forgot to mention, so in notable examples, notable platforms that use React is Facebook, Instagram, Netflix, Airbnb, Uber, all the major players, they all use React. And for Angular, it is mainly for Google platforms. So there's Google Ads, Gmail, famously one of the oldest the web-based full application written. So and then there is Office 365, where there is PayPal and Forbes. Next up is Vue.js. So this is also a modern JavaScript-based front-end framework, and it is supposed to be much lightweight and more flexible and friendlier than React and Angular, because Vue is much younger than the other two, so it has learned from the older frameworks that came before it and implemented lots of improved standards and ways of working. So it is popular among new engineers learning to develop web applications, and it has got a loyal and growing community. The pros are it is fully featured, even though it is much younger than the other two, and it's got out-of-the-box support for routing, state management, testing, and all that. It is strongly typed, unlike React and Angular, which don't necessarily need a strongly typed language. You have the option to, but it's not enforced. But Vue, on the other hand, enforces a strongly typed language. It is very opinionated, which means that it is batteries included. You don't have to make a lot of choice. You just choose to use Vue, and that's it. You don't have to make many further choices beyond that. So that improves your, that gets you started much quickly. Cons, it is it's known for having a much smaller talent pool because it is not as popular as React or Vue.js. I'm not too sure about these 2 points. I think that was written for a different slide. Again, there's been some kind of mix up over there. Apologies for that. Notable people using Vue.js are Alibaba. What was this one? I don't quite remember what that logo was. Grammarly and Behance. And coming to the mobile development. So in mobile development, like I mentioned before, we'll be looking at cross-platform application development frameworks so that you write once and deploy multiple times. The first one is React Native. So React is to web what React Native is to mobile, basically. So it's like you take React for the web, you take the same programming paradigm and apply it to mobile application development. That is what React Native is. So again, it's developed by Facebook for developing their own mobile application, and it's become super popular alongside it. And it is one of the two dominant mobile development frameworks right now, next to Flutter, which we'll see next. So it is massively popular. Like Flutter and React are like neck to neck when it comes to market adoption. But the pros are that it's a very easy transition for React developers because it uses the same paradigms, same language, same everything. Just the UI component library that you'll be using is different. So there is some learning involved in that. But if you already know React, it is a very easy jump into React Native. And that also makes it an advantage in projects that use both React and React Native for their front end. So you could have one repository which maintains the UI for both your platforms, and then you could share a lot of code between the two because everything is JavaScript, everything is React, right? And just like React, React Native also has a very rich ecosystem, very strong community, lots of libraries, frameworks, and components out there that you can choose from. There's no shortage of choice out there. And while you're writing mostly in JavaScript or TypeScript, if you do need to reach into platform features which are available only to native code, there are libraries out there which provide this integration. And worst case, if the specific integration that you need is not available, you can always write your own native language code and bindings for it, which is usually uncommon because most of the time you need somebody's written a library out there to make that happen. Cons, it's not as fast as native apps because unlike native apps, which are compiled to be super fast, React Native uses JavaScript, which needs to be interpreted at runtime. So it's slightly slower than a native solution. And platform-specific adjustments may need to be written because like you're developing for Android and iOS, which have very different, similar, but different UI paradigms as well. So you might need to write specific tweaks here and there based on what platform you're running on. And they do provide tools for that, but it is something that the developers may have to keep in mind. And like React, battery is not included, which means that you just get your React Native framework, but then you have to bring in some kind of build tooling. You'll have to bring in a component library, a testing library, and lots of other things. Again, there are the pro that is the rich ecosystem and community support also becomes a con because now you have a paralysis of choice. When you start a project, what do I choose from? What framework do I select? Again, there are opinionated solutions for many of these things, but again, you still have to make a choice to select that framework. Like, for example, one of the most popular ways of developing React Native applications is Expo, and Expo makes a lot of choices for you, which simplifies some of this, but still, there is still a lot of choice still left to you, like what UI component library should I use, and that sort of thing. Next up is Flutter, which is our favorite baby. So this is what we use at Automate to develop our applications. And like I mentioned, it is neck to neck with React with a slight edge. So if you look at the stats over there, it says that 9.21% adoption versus 9.14% for React Native, like really, really close, right? It's uncanny how close they are. Developer satisfaction of 68% versus 64% for React Native. And like React Native is developed by Facebook, Flutter is developed by Google, right? And which means that you'll be using a slightly different paradigm, and it uses a different programming language as well. So it is the advantage is that it has built-in support for mobile, web, and desktop. So in theory, you could write one application which runs on mobile platforms and on the web browser. It may not be the most optimal approach to building websites, but it is possible if you want to do it. And Another advantage that Flutter has over React is that unlike React or React Native, which is using JavaScript in your mobile phone, Flutter is compiled into native. What that means is that it takes your code and then it generates a binary that is optimized and can be executed directly on the CPU of the mobile phone, which makes it much faster. So if you want to build performant applications, which got lots of runtime code that it has to execute, you probably want to reach out for Flutter. And another advantage that Flutter has over React Native is that it's got a built-in widget toolkit, which allows for rapid prototyping. So unlike React Native, you chose React Native. Now what? You need to pick a library. Now what? You need to pick a testing library. So you don't need to make all those choices with Flutter because it comes with many of the stuff included in the box as batteries included, right? If you still want to, if you say that, oh, I don't like the component library that comes with this platform, I want to pick and choose my own, you can still do that, but you don't necessarily have to, right? So that is the advantage of Flutter. So the time to market with Flutter is very short. And it got a custom rendering engine, which means that unlike React Native, which uses the platform's own UI widgets and stuff like that, Flutter has its own component library and rendering engine, which gives you a consistent look and feel across all platforms. But the sharp-eyed people might notice that it is not exactly a native application. With React Native, you can actually write an application that masks the fact that it is not a native application. If you write it, if you're in the hands of a good developer, a React Native application will be indistinguishable from an application developed using Apple's or Google's own technology, Kotlin or Swift. But with Flutter, you can probably notice it because it uses a custom rendering engine. That being said, it is not an issue. Most of your customers will probably not notice it. And in return, you get a faster, high-performant application. The cons are that it uses the Dart programming language, which is not as popular as JavaScript or TypeScript. JavaScript actually happens to be number one or among the top two of programming languages out there. And it runs on a lot of different places, right? It runs inside the web browser, it runs in the mobile through React Native, it runs on the backend through Node.js, which we'll see later. So it is super powerful, which makes JavaScript really popular. But Dart, on the other hand, doesn't have as many users, so there's not many people who know it. So if you want to pick up Flutter, the engineer will have to learn Dart. While there are third-party libraries available for Flutter, and you probably won't need a lot, but there is still a fewer choices available compared to React Native. And while native support exists, it is kind of limited as well. Popular applications include Google Pay, Alibaba. Alibaba seems to have a hand in all the technologies, by the way. So when I was researching this, I found Alibaba's name appearing again and again in pretty much all the tech stacks. So it looks like they're a massive company and they use whatever tool they can get to get their work done. BMW, eBay, and Tencent. Another choice that you have when you're developing mobile applications is to not develop a mobile application, which is where tools like Ionic sit in. Which what they do is instead of developing a native application, you take your web application and put it inside a native looking package and then ship it off to customers. That is what Ionic is. So it uses standard web technologies like HTML, CSS, JavaScript, and then packages into a mobile application. This type of application is called a hybrid application because it uses web technologies and it uses some native interfaces through Ionic's own APIs. And you can use familiar frameworks. Like we saw the three popular web frameworks earlier, Angular, React, and Vue. You could pick any of them and you could use that inside an Ionic app. So let's say that you had a web application developed, and now your users are craving a mobile application. You could take your web application and port it piecemeal into an Ionic mobile application. It does save you a lot of cost because now you're just repurposing what you already built for the web. But with that advantage comes the disadvantage that it is definitely not native, and teen users can tell the difference. And it is unanimously considered a substandard UX, so it is not used as commonly. Pros, as I mentioned, single code base. You could take a web application and put it in a mobile platform, and then you're done. Short learning curve because you already have learned web technology. So all you need to do is learn a few Ionic APIs to do some platform specific stuff. And progressive migration, that is where the cost saving comes in. So you've already built a web application, you can port piecemeal little by little, right? And you can do it in stages so that it accelerates your time to market and you can take a longer time to finish your entire project. And it's got a vast library of plugins to take advantage of native features if you need to. Cons, it cannot compete with Flutter or React Native in terms of native feel and performance. That is a given because it is basically a web browser inside an app. You need to also, the other disadvantage is that if you just leave it to the engineers, the developers, they probably won't do a great job of making your Ionic application look and feel like a native application because it's not built into it. You need to take extra effort to make your Ionic application look and feel native. It is possible, but it is not in the happy path. It is something that extra effort needs to be taken. And because of that factor, most Ionic applications tend to generally have a inferior UX compared to native applications. It works for certain projects where it's not as important. If your mobile application is like just a utility that your users are just going to get in and out of, you might be able to get away with it. But if your application is anything more serious than that, if you're expecting the users to spend significant amounts of time inside a mobile application, then you are recommended to consider one of the other alternatives. Popular options include, popular clients include MarketWatch, SWorkit, that Discord, I'm not quite sure. Instapot is some kind of a pressure cooker application, a pressure cooker company, and Shipit. So you kind of by the kind of clientele that these libraries have, you kind of tell what they're good for, right? So if a pressure cooker company is using it, you probably don't want to reach out to this one. That's a duplicate. All right, moving to desktop. So for most startups, you build a web application, and then as a next step, you probably build a mobile application and you call it done. That's your front-end story, right? That is probably all you need. But sometimes for some startups, you want to build a desktop specific solution because there is demand for tooling on the desktop. And if you need that, there are many choices out there. One of the most popular cross-platform desktop application development tool is called Electron. What Electron does is kind of like Ion is kind of different, and because it is a desktop, your user interface does not need to look like a mobile application, and an application. A well-designed web application will fit really well inside a desktop app that you download off the App Store or something like that. So for that reason, Electron is a much better choice for developing desktop applications than Ionic is for developing mobile applications. So similar to Ionic, you'll again be using standard web technologies, HTML, CSS, and JavaScript. And you can use popular frameworks like Angular, React, and Vue, which you've already learned. So all of that advantage comes with it. Electron was initially developed by GitHub and is now maintained by the OpenJS Foundation. And the reason for developing Electron was that GitHub wanted to build that IDE, or integrated development environment for developers. It was called Atom, and there was they wanted to leverage web technologies, and there was nothing out there that would help to do that. So they developed Electron for it. Now Atom has been retired, but now you probably have heard of this guy called as VS Code. So VS Code is now the most favored a development tool that most developers like to use. And this application is really well written. It's like the champion for Electron, and it does a really good job of feeling native and integrated. And other popular applications that use it, you are like Slack, Discord, Twitch, Figma, and they're all considered like very top-notch applications. That kind of tells you what Electron is capable of. So if you compare it to Ionic, it's a very stark difference. Very similar technology, but look at the companies that are using it, whereas with Electron, you really find high-end applications. So pros, like I said, shorter learning curve because you're reusing your vector technologies. You can share code between your web application and your Electron application because they're essentially the same thing. And it uses the Chromium rendering engine, which is basically what powers the Chrome web browser. So your application will look, if you develop it on the Mac OS, let's say, it'll look exactly the same on Windows and on Linux because Chromium will ensure that. And then just like Ionic and others, there's a vast library of plugins that you can use to add additional functionality to it. But Electron is not without its downsides. So its cons include very large app sizes and memory footprint. This happens because every application needs to bundle a build of Chromium inside it. So it's not just your code. It's like shipping an entire Chrome web browser with your application every single time. So that is a very large app size because it's a browser running inside your code. Web browser has a lot of overhead. So typically, if you write a native application, let's say take like 50, 100 megabytes of RAM, a similar application written in Electron might take nearly a gigabyte of RAM. That is the downside of it. That is why developers nowadays use beefy machines because half the applications that they run are Electron-based. And since it is web technologies, it cannot match the performance of native applications. Although JavaScript has become really, really good at high performance stuff, there's a lot of games and 3D rendering and all that stuff being done. So anything that runs inside a web browser can run at the same performance in Electron. But even though it's really close, it still cannot compare to something that you write in the native platform language. Next up is Qt. So this is the only other desktop technology that we'll consider. So Qt is it's got its origins in Linux. It's like a UI widget toolkit that is generally used to write applications for Linux, but it is actually cross-platform. So you could use it to develop multi-platform applications. It is written in native languages like C and C++, and it's got lots of support for 3D rendering. So it is kind of really high performant. So and since it uses the platform's own UI components and stuff like that, you get a native feel. So you write this application in Qt and you run it on macOS, it'll look like a macOS application if you choose to. And same for Windows, right? Which is actually an advantage. And it is an enterprise tool. It is a commercial tool, which means that there is really good tooling on it, and it is really scalable. It's been around for a really long time, and they've been working on it for decades. So it's highly scalable from very small applications to enterprise grade applications. Cons being that there is a steep learning curve in terms of the languages that you have to learn. So C++ is a dinosaur at this point. It is from before the 2000s, right? It's really old, and modern developers do not favor learning those old languages. So that is the downside of Qt, and it is also not free, right? If you want to use it for commercial purposes, you got to buy a license for it. So that was your front end story. Now coming to the backend. So the first kind of backend that we will consider is out of the box solutions. Like these are called backend as a service. So instead of instead of spending a lot of money on writing a backend from the ground up, you use pre-built off-the-shelf backend services, and then you customize it to your needs. The first of this class would be Firebase. So this is a backend as a service developed by Google. And the way it works is that you go to Firebase, you sign up, and then you set up your data models. You set up what your schema looks like. You set up events, and you write code to execute on certain events that are fired. Let's say that you are writing a to-do application, right? And you want to host it on Firebase. So you'll say, okay, I have a to-do. A to-do has an ID. It has a title. It has a description. It has a checkbox that says, is it done or not? And that's it. You have now configured the API required to implement a to-do application. That's it. You don't have to write a single line of code. But if you want to do custom behavior, like when the user completes a task, you want to move it to an archived list or something like that. So you could write a special function that executes when the user checks the checkbox that says done, right? So you can customize that way as well, right? And in addition to basic functionality like that, you've got a built-in authentication, because now authentication is the key. Whenever you come to backend, you probably want to support authentication, which is that you want users to be able to log in to your application because they have their private data in your server. So that is where authentication comes in. And if authentication is built into a service, then that is a bigger advantage. The other one is real-time database. What that means is that let's say that a user is having two devices. You update a to-do on one application, you instantly get an update on the other application. That is a real-time database. So this is especially useful when data is shared between multiple users. So as one user updates it, the other user instantly gets it. That is a major advantage that if you were to build it from the ground up, it is a lot of work. It is not easy. So being able to leverage that from the click of a button is amazing. And in addition, you have things like file storage. Let's say you want to upload images or something like that, attachments to your data. You could use file storage, or you want to send push notifications. Let's say that your to-do has a due date. So as the due date approaches, you want to send a reminder to your customer. So that is where you can send a push notification. And then analytics. So yeah, analytics actually is an important thing. So when you're developing an application, you want to know how your application is being used. Who are the people? Where are they coming from? And what are they doing inside your application? So that is where analytics comes in. It collects all that data for you. And in addition to that, Firebase also allows deep integration into Google's services because it is Google's baby. So the advantage is that it is fully managed. So you just go sign up, you configure some stuff, and then you're done. You have a backend ready. And everything from the database to scaling to how rate limiting, all of that. You don't even have to think about all of that. It is just done for you. You get real-time capabilities out of the box. We talked about what they are. And you get easy integration with other Google Cloud services like push notifications and analytics and all that stuff. So yeah, this is Firebase is what we also often reach to when we want to build a backend for our customers, because like I said, bang for your buck. You want to spend a little bit money and get a lot in return for it. So Firebase is our number one pick for that. The cons of Firebase is that vendor lock-in. So this is going to be a prevailing theme in our backend thing. So most of these backends are have some kind of vendor tie-in. So here the vendor is Google. So now once you build your complex application on Firebase, you're now tied strongly to Google, which means that when your application scales, you'll have to pay whatever cost Google demands. And that is actually a con of Firebase. So as your application gets larger, it can get pricey. So while it was cheap upfront, as your application grows, it might become less and less viable. But then at that point, most startups, what they do is they now slowly move functionality out of Firebase into distributed services. So it won't be a cost in a realistic scenario, because if you're successful, you will have ways to mitigate the cost by moving more and more features out of Firebase into your own custom backends. The other thing is it uses a type of database called as NoSQL. We'll see what that is towards the end of our presentation. So a NoSQL database is not ideal for all applications, but I won't go into the detail of that because that's a lot of theory. It has limited control over infrastructure and backend logic, because this is like a solution that's come out of the box. While you have some customization over it, a lot of that is already built for you by somebody else. You don't get deep control. So who's using it? Duolingo, Vimeo, again, Alibaba, Trustpilot, the New York Times. So you'll find people like Alibaba, New York Times, they use a lot of these services. So you'll see them dipping into pretty much all technologies out there. Next up is Supabase. So as the name suggests, it's got something to do with Firebase, and it's that it's an open source competition to Firebase. So people, were getting or they logged into Google, and they wanted to have a solution which they can manage. So that is where this open source community came in, and they developed Supabase. It's relatively new compared to Firebase, so it's not as mature, but it does have a large number of the core features like real-time updates, authentication, the APIs that automatically generated from schema, the event-driven functionality, that's what edge functions, file storage, and etc. But curiously, it doesn't have analytics of its own, so you'll have to bring in another vendor if you want analytics, and any other service that Google provides, Supabase won't have it. So upsides, it's open source, no vendor lock-in. It uses Postgres as the database. That is a fully relational database. Again, we'll see that in one of the latest slides. And it provides easy integration with the front application, just like Firebase, by the way. But cons being, it's less mature compared to Firebase. And it is not exactly known for its scalability. So while Google may charge you money for scalability, they can scale. In fact, they are probably the company that knows how to scale, right? They run Google after all. So scaling is not a problem with Firebase, but it could be a problem with Supabase. And it does require a lot of developer familiarity with the backend and the database that they use. And if you're using a self-hosted way of running Supabase, which means that you are managing your Supabase instance. You're not paying money to Supabase to do it. As in, it's free, but it relies on you having the expertise to manage it. If you don't want to do that, Supabase does provide paid options where you pay Supabase like you would pay Google to host it for you. But then you will encounter similar issues as Firebase in terms of cost when you scale up. Notable people using it. So Firebase, Epsilon3. Epsilon3 is a company that does rocket stuff for NASA and all those players. PricewaterhouseCoopers, Johnson & Johnson, and 1Password. Many repeats. So next up is AWS Amplify. So this is Amazon's answer to Firebase. It's got very similar capabilities. And if you didn't know it already, by the way, Amazon's biggest service is not its store. It's actually what is called as Amazon Web Services, which is where they make most of their money. So a sizable chunk of the internet runs on Amazon services. So you can hire their infrastructure to run your applications, which we'll come to later again. It's as one of the hosting providers. AWS Amplify is their solution is their answer to Firebase and other backend as a service providers. It's got deep tie-ins with other AWS services. It does provide a matching set of features from as Firebase does, but it leverages other AWS services to do that. For instance, for authentication, you can use Cognito, which is another AWS service, AppSync for API, DynamoDB for database. So these are all other services that you will have to pay money for. Pros, seamless integration with AWS because it's their baby, and it's got both GraphQL and REST API. These are technical terms. You don't have to worry too much about it, but it just is basically the kind of language that the application and the backend use to talk to each other. So there are two different popular ways of talking to each other called as REST APIs and GraphQL. So REST APIs are slightly older, GraphQL are slightly newer. They are both equally popular. They have both their advantages and disadvantages. And a notable thing about AWS is that it's got built-in support for artificial intelligence and machine learning capabilities. But again, it's another service from AWS that you have to hire for that need. And cons being, AWS is known for its complexity. So they have been running servers for a while. There's a lot of baggage there. And every so often they add a new type of service to it and it gets incredibly complex. So if you're going to use anything to do with AWS, you probably need an expert in your team who can handle that stuff. And as with most backends, there's a vendor lock-in, Amazon in this case, and also a steep learning curve. So who's using AWS? So that's Amazon Music, Neiman Marcus, which is like a luxury retail chain. Noom is an application for fitness and the healthy eating, and an insurance company called State Auto, and Credit Genie, which is like a lenders union or something, not quite sure. So what we saw so far was backend as a service. So it provides full-fledged API for most applications, but sometimes you don't need that much. So now you're going to a lighter form of backend called as content management systems. So what is that? So let's say your startup idea is to develop content for user consumption. Maybe it's a magazine, or maybe it's a platform for people to share and upload artwork and show it to the users. So it's like if you have a core set of content that is shared among all of your users, you probably want to reach for something called as a content management system. The most famous one of this is WordPress. You probably have heard WordPress in your daily lingo, but we won't be using WordPress because it's a full stack implementation. It's got its front end and it's got a back end, and it's mostly used by bloggers and stuff like that. We will be talking about something slightly more advanced called as a headless CMS, as in it doesn't provide you the front-end application. You have to build it yourself. So of the most popular one, we look at just two of them. Like of the popular ones, there are many choices out there. So if you ask anybody, what's the best CMS? What should I use? There's going to be a lot of answers you get. So I picked two of the more well-known names. So Sanity is a commercial solution. So they have a free tier, but if you want anything serious, you got to pay the money. But the advantage is that it is hosted by them, so you don't have to worry about anything, databases or scaling or anything of that sort. And the other advantage is that their UI, when I say headless, by the way, your client or your customer is not seeing the CMS UI. You are building a front end for them, but you as the application developer will have a admin portal where you can manage your CMS. So headless doesn't mean completely headless. There is still an admin portal. There is still a UI that you use, which is for internal use only. So Sanity also does, which is written in React, which makes it kind of easy to customize, by the way. So if you have an engineer in your team who knows React, you can probably use their skill to customize the UI to your needs. And similar to backend as a service, you'll also be defining what your data looks like. So let's say you have magazines, you have authors, you have collections, you have articles. So you can create all of these as entries in Sanity, and then you can link them together. You can say a magazine has many articles, a magazine has many advertisements, a magazine has many authors. An article can be written by multiple authors. So you can maintain all these links, and this can all be done in a visual manner. You don't have to write any code. You can just do it in a drag and drop manner. So that is where their admin tool comes in. And then very customizable schema, very customizable UI. If you want to do custom stuff, you can. So Sanity can take you a long way without having to actually implement a more heavyweight backend. So it's got real-time editing capabilities. So let's say that you have a team and multiple people in the team are working on an article that you're trying to publish. The next day, they can collaborate together in real time over the internet to edit that article. Right? So that is where the real-time editing capability comes in. It's very developer friendly, and it's got excellent API and a nice CLI that can be used. So cons are is that if you want anything serious, you got to pay money, right? So if you want most basic thing, like a hobby project, you can get away with the free tier. You can use that to get started in your development. But once you want to go to production, you got to pay the money for a proper enterprise level or a business or enterprise level support. And if you're doing something simple, if you don't have a complex content management application, you probably don't want Sanity. There probably are simpler solutions out there. Maybe WordPress may be good for you, or maybe the next candidate in our list, which we'll come to next. And then this is hosted by Sanity. So this is on Sanity's cloud infrastructure, which means they maintain the scaling and all that for you, which can be an advantage or disadvantage when you get big. As you get big, the trend is that you want to take control of more and more of your backend and systems. So at that point, having a third party maintain it for you can be a disadvantage. So popular uses: Spotify, Puma, Condé Nast Traveler. So that is a magazine, by the way, as an example. Morning Brew, another magazine. Sonos. Next in our list is Strapi, not to be confused with another tool of a similar name called Stripe, which is for payments. Strapi is for CMS. So Strapi is an open source alternative. They have been in development for quite some time. It's very mature, and it provides pretty much all the leading features of the most popular headless CMSs out there. And it does provide a self-hosted solution, which means that you can manage your Strapi instance yourself. I've done it in the past. It's not too hard to do it. And that way, when you become a large enterprise, you still have complete control over it. And because it's open source, you can make any edits you want to the CMS. You can build in custom features, and Strapi is highly extensible, which means that even though it's just a CMS, you can actually build a full-fledged backend out of it because they provide all the tooling out of it. It's not the right tool for the job, but you can still do it in a pinch if you want. If you have a complex CMS application, but you want to build in a little bit of custom out-of-the-way functionality, you can do it without having to build a completely different backend for that need. So it is advantages that it's open source and free, and there are commercial options if you want to leverage that. So if you don't want to host it yourself, you can pay the Strapi company money to host it for you. And then at some point, if you want to, go independent and host it yourself, you can then export your data and host it yourself. So that is an advantage. It is highly flexible and customizable. It can handle a lot of different types of projects, and there is a active community building extensions and plugins to even make this even do a lot more things than it was originally built for. Cons, it requires custom hosting and maintenance to take full advantage of. So you can, as I said, you can pay money to Strapi to get started, but if you want to take full advantage, you want to manage the instance yourself, but that does require somebody in your team with the skill to do it. And then the other thing is, while this is a simple CMS, if you want to scale up to large volumes of users, you'll have to build mechanisms on top of that to facilitate that. There are, of course, well-known solutions for all of that, but again, you need to build it. And while customization is not needed for everybody, if you do, it's not a standard thing, right? It's not like a popular tool that most developers use. So it's something that they will have to learn how to customize. Who's using it? Netlify. So Netlify is
sorry, Rakesh, just
sorry.
a quick time check for people as well. So guys, we still have, the stuff about database to go through. I know it's 1:05. We might need another 10 minutes. So we can try and wrap up by 1:15. So just keeping people updated on the time, Rakesh. Plan was to
All right.
Finish at 1, but we still have database to go, so we might need another 10 minutes, guys. Just doing a little time update for you guys.
Yeah, apologies for that. As you can see, there's a lot to cover. Yeah, so I'll try to speed up for the next few things. So now we come to the serious work. So if you want a fully custom backend, you want to write the entire thing yourself, right? So at this point, now we're talking about low-level frameworks and languages. So .NET is Microsoft's answer if you want to build a completely custom backend. It has been around for a long time. It is very popular and it's got lots of tooling, but the downside is that it's got a steep learning curve, and then it is not perceived as trendy. So there's not a lot of people wanting to learn .NET. But surprising thing, .NET is really popular in Australia. It is the most sought out backend technology in Australia. So you do find a lot of talent in Australia for this, but probably not the rest of the world. But Australia is uniquely positioned for .NET. On the other side of the river is Node.js. So Node.js is, so earlier we talked about the Chromium engine. So the Chromium, when we were talking about Electron, so the Chromium is the engine that runs the Chrome browser and Electron UI. So that is powered by a JavaScript engine called as V8. So V8 is just a JavaScript runtime. So somebody took that runtime and said, what if we use that to run code on the server? So that is how Node.js was born. And it is now really popular among a lot of startups and a lot of big enterprises as well, because now you can leverage JavaScript to write your backend. And the advantage is that one language everywhere, JavaScript backend, JavaScript frontend, JavaScript mobile application. So you could learn you could hire one engineer and potentially he could scale to the entire stack. Right? So that is where Node.js's advantage lies. And it is as competent as any other framework. It is really good for high performance stuff where there's a lot of I/O. I'll not go into what that is. But if you want like CPU heavy computations and stuff like that, you probably don't want Node.js. Next up is serverless. So this is not exactly a framework or a language, but it's more of a paradigm. So oftentimes you want to write your business logic. You don't want to think about how it's hosted or where it is running. How do I scale this to lots of services? So what you do is you reach for this paradigm called as serverless. So in serverless, what you do is you write small pieces of code that execute when certain actions are triggered. For instance, going back to the to-do application, your user creates a to-do. So there will be a small piece of code called as a function. this function will be attached to the create to do event. It'll just take the data that's coming in, put it into the database. And then the user is now trying to edit the description of this to do. So there might be another function to update this thing. So you write small pieces of code, and then you give it to a service that can manage and orchestrate all this. And that service will take care of bringing up and down these functions as and when the demand arises for them, right? So that is what serverless is for. And one of the more popular ways of hosting serverless is through AWS, which is, we saw that earlier, Lambda. The advantages is that because of the way it's structured, you get pay-as-you-go pricing, which can be cheaper in the long term. But the downside is that since it's like lots of small pieces, they are brought up and down as needed. So it could consume a little bit of time for your application to start up. Coming to databases, so there are many different kinds of databases. So we'll be looking at 3 of the more popular types and 1 example of each. So the classic database is called as a relational database, where you maintain different tables with relations to each other. So for instance, going back to that magazine example, so when we are talking about schema, what you're talking about is the different entities in your data and the relationship between them. So you have a magazine, magazine has articles have authors, and then you could have a magazine has advertisements may have vendors, and so on. So you could maintain a network of links and collections of data called as tables. So that is what a relational database is. It is very robust, and it is the most popular way of storing data. And Postgres is a open source way of hosting this, and it is really popular among modern applications. And it is highly reliable, very performant, and it is proven in production. And it has got most of the features that you would expect out of a database. But as most things, Postgres also has a learning curve, and then it might be overkill for smaller applications. And if you want to do a smaller application which has got a lot less need for data, you want to reach for something like MongoDB, which comes under the category of NoSQL. In a NoSQL database, you're not storing relational data. Instead, you're storing documents. So you can have unstructured documents, and then they just stored inside like a loose collection, and then you can search through them and extract them and stuff like that. So it is not really good for maintaining strong relationships, but it is good for simpler data structures where all you need is to just put something in a place to store and retrieve it on demand, right? So that is where services like MongoDB come in. And it is very flexible for handling unstructured or data that is changing rapidly. So that is one of the disadvantages of a schema-based RDBMS. So when your data changes, you gotta take a lot of steps to move your old data to the new structure, right? So that is called as a migration, which can be a lot of development effort to set up. But with MongoDB, that is not an issue. It can handle changes in data very easily, very fluidly, and it is also scalable. You can use this for massive applications, and it is very easy to use because it's just it's got libraries that integrate with front-end frameworks. But the cons are that if you have complex queries where you want to extract based on relationships and stuff like that, it cannot handle that, and you need to do a lot of tuning to get performance right. It has a historic limitation for transactions. But as in, a transaction is a mechanism where you make multiple updates, but they don't stick until all the updates go through. So it's like an all or nothing change. That's called a transaction. Not going to the detail of what that is, but that is important when you're storing data, long story short. So, and for people who are used to traditional SQL-based databases, a NoSQL database might be a shift in the mindset. And the final kind of database that we'll cover today is called as Redis. It is a specialty database, and specialty databases serve specific needs. And in that, there are so many different kinds. And this particular one is called as a in-memory database. So it's called an in-memory key value store. So what is this used for? It's used for storing data to be retrieved really, really fast. Or in other words, in programming paradigm, it's called as caching. So let's say that you have a big database with lots of data, and then like 100,000 customers are trying to access it all at once. So if our backend tries to hit that database and tries to extract that data, the database is going to croak. It's not going to be able to handle this load of 100,000 users trying to simultaneously access it. So what you can do is you can utilize a technology called as caching, whereby you read the data once, but you load it in a place where you can retrieve it very quickly, right? And then when the next user tries to access that same data, you already have it read. You already have it in memory. You just send that to the customer. So that makes your application very scalable. So you will hear Redis a lot when it comes to scaling your applications. So if you want large volumes of customers accessing a small set of data, you want to reach for something like Redis to provide an extra layer of caching. It is blazing fast, and that is being the biggest advantage. It is simple to use and set up, but the downside is that it is limited by the capacity of your machine. How much RAM does it have? So if it's really massive, then massive data, then you will be limited by what your machine can handle. And finally, comes to hosting. So now you built all of this. You've got a front-end application. You've got a lot of back-end services. You've developed all this in your development shop, and now it's time to deploy to production. So at this point, you want to look at hosting services. So hosting services are places where you run your service. So you don't hire a data center yourself, right? You just look at service providers which run the data centers for you. You just say, hey, I want this server with so and so capabilities, and I want to hire it at this cost, and the service providers will give it for you. So that is what a hosting service is. And as I mentioned earlier, Amazon AWS is the most popular candidate out there, and they have a lot of different types of services in their bucket. Everything from simple servers to what is it, Lambdas, which is basically used for serverless, to AWS Cognito, which is used for authentication, or S3 for storing files and stuff, and tons of AI-based services, and tons of auto scaling services. So the thing is, it's like a very deep pool, right? So if you jump in, you're not gonna be surfacing for a long time. Long story short, everything you probably need in a hosting service, Amazon probably has it. And it is highly scalable, and it's proven because half the internet uses it, right? So if Amazon AWS goes down, half the internet will go down. And it has happened in the past, by the way. So there are stories where Amazon went down and half the internet went down with it. The cons are that it is a steep learning curve. It's been in existence since Amazon originally started as a book selling company, right? That is when they started developing the stuff. So it's got a lot of old baggage. So that means there's a steep learning curve. And the thing is, you can easily lose track of how much you're spending on Amazon, right? Because you add service after service, you set it to auto scale, and then it makes lots of decisions for you, and that decisions may incur in high costs. So you want an expert in-house to keep an eye on this. Finally, I'll go to something that simpler startups use. There are many alternatives out there, like Netlify or Vercel or DigitalOcean, which are much simpler versions of hosting, right? Much more suitable for startups. And one of the tools that I have used in the past is called Heroku. So Heroku is basically a much simpler platform as a service solution, whereby you write your code and then you deploy to their services, and then they take care of running it for you. You just say how many instances of the server do you need, or how you should auto scale it. Maybe you say, at a minimum run one instance, but as the user scale, go up to like 10 instances. Maybe that you could configure that, and then you can also hire a database from them to store all of your data. So it is usually much simpler to get started on Heroku, right? And they've got lots of developer tooling that makes integration easy, and then it's very effortless to scale horizontally. And you can scale vertically also using saying that each instance needs to be a beefier machine. There are free tier options, but that will not cut it for productions, of course, but you can get started in development. But the downside is that with convenience comes cost. So because they provide all of the service, they are going to charge you money for it. So the moment you start scaling to larger applications, your cost will very soon start rising. So you don't want to tie into this one, which is another problem, by the way. You're going to be vendor locked in with a lot of these things, but not as much with Heroku. You can still port your thing to run on a different service. But you can use this to jumpstart your project, but you don't want to use this for running your thing long term. You want to then divest and maybe hire an AWS expert in-house and run it on their servers. And it's not ideal for massive, high performance applications. It's good for smaller scale startups. For instance, earlier we talked about Strapi as a CMS, right? You want to run, where do you host it? You host it on Heroku, right? Because they have a built-in a tool that can let you launch a Strapi as a service, and then you're done. Yeah, but we don't want to keep this for long term. So in conclusion, we saw a lot of toolkits, and this is going to be the theme going forward as well. And as the days go, there's going to be more and more of these different frameworks to choose from. So how do you choose between all of this? At the top of your list should be how much money do you have, right? Because that is what is going to affect your decision in the ultimate sense. Finally, once you know how much money you have, the next is what is available to you. So oftentimes you're going to reach out to third-party vendors to develop these applications for you. So let's say you reach out to us, Omate. So we will recommend what is suitable for your project. So that is basically where availability comes in, right? And then you can trust us to make the right choice, but you also want to be aware of what your choices are, right? So once you choose that, the next step is rapid prototyping and time to market. So once you have narrowed down your choice to what is available to you, you want to decide which of these is going to get you to the market the soonest, right? So you got to find a balance between off-the-shelf components that can get you to market really, really quickly versus features that you want to build in your startup application, right? Your startup application might be simple, like a magazine. Yeah, you got to go for a CMS. Time to market, really, really short. Only time it takes is to hire a few authors and write your content, right? But you might also be building something complex, like maybe you're developing the next big breakthrough in AI, in which case you want to go all in. You want to go for an AWS-based solution or something like that, right? So again, you want to see out of all the tools out there, which of these is going to meet your needs and get you to the market the quickest. And once you get to the market, then comes the lesser and less. So as you go down the ladder, these are decisions that you're taking later and later in your project, right? So once you have this, the next thing is flexibility and maintainability. So you want to consider, if I choose this framework, am I going to be able to continue using this 1 year down the line or 5 years down the line when my company has grown to a large size? Can this scale? Can this extend to meet my needs? And next rung in the ladder is now you're successful. You are getting 100,000 customers, maybe a million customers based on your size. So at this point, your problem is entirely different. Money is not an objective anymore, but scalability is. So your choices you made earlier might affect, what is available as scalability later, right? So by this time, you probably want to be thinking about your long-term goals, and you may have started on a simple platform like Heroku, but over time, you should, by the time you get to step 4, you should have moved out to a bigger service like maybe AWS or at least something like DigitalOcean, where you can get scalability for much cheaper, right? And finally, adaptability, right? So now you have a scalable solution. You pick AWS. How adaptable is it? Can it meet the emerging needs of a future market? So this is something that is now harder to judge, right? This depends on what your needs are, how the market is changing, and how well your technology stack of choice is adapting to the needs, right? So let's say something like React. React has been around for more than 10 years, right? But it's also highly successful, and because of its massive momentum, you know that they're going to continue maintaining it. Same for Flutter, right? So Flutter has got a massive popularity among young startups for mobile applications. So you know Google is going to continue maintaining it. So you're probably safe in terms of adaptability, but is that sufficient? So maybe your needs evolve. So maybe your needs go from a simple mobile application to a more complex one, which needs a lot more performance and CPU time. So at that point, you want to rethink your tech stack and move on to something that more suitable to you. But as you go deeper into you start at the top, right? And then as you go down this ladder, down these stairs, you're going to build your expertise. And by the time you get to the third or fourth step, you already know exactly what you're doing, and you probably won't need my assistance in figuring this out. So long story short, prioritize technologies that can support your startup's immediate needs while also laying the foundation for long-term growth. So think in the short term, you need to get to market, money. In the long term, you need to be sustainable.
Awesome.
So thank you for listening. I know we have overshot our time, and I apologize for taking the extra time. But if you have any questions, now is the time to ask.
Wonderful. Doesn't look like there are many questions there.
Yeah.
Wonderful.
Let's
Yeah,
move
thanks,
on then.
Rakesh. Thanks, Rakesh, once again for the session. Yeah, just the last slide, guys. I put a bit of my team there as well. I'll put my Zain's here in the call, who's our head of product strategy. So we will leave our emails here. Zain, if you're still online, I'll give you an opportunity to show your face and say hi. So
Yeah, still
guys,
here.
if you have
got the camera on here, so thank you everyone for joining. Rakesh, thank you for the information as well. It was super informative. So yeah, I'm happy to help. There's my details just on there as well. So if you want to reach out, please feel free. Happy to help anyone out here. Thank you.
Thank you
Wonderful,
all.
guys. Thank you all. Yeah, take note of our email, and yeah, let us know. Like if you need help with anything, if you're in the process of building your app and you have questions, reach out to us. We are always happy to help the community. So thanks again for your time. We'll chat to you guys in another time.
Yeah, thank you all. Thank you all for bearing through this 1.5 hours of presentation, and have a good rest of your day.